Here is a RAG failure mode nobody warns you about. Your retrieval is tuned, your prompts are sharp, and the answers are still garbage. Not because of the model, because the documents were mangled the instant you loaded them. Real-world PDFs are full of tables, multiple columns, headers, and scanned pages. A basic text extractor reads the raw byte stream, which has no idea about visual structure, and it turns all of that into scrambled soup. Look at what actually breaks. Tables collapse, so the rows and columns flatten into a meaningless run of numbers, and a price drifts away from the plan it belongs to. Columns interleave, so a two-column page gets read straight across, splicing unrelated sentences together. And reading order breaks, so headers, footnotes, and captions land wherever they happen to sit in the byte stream. Garbage in, garbage chunks, garbage retrieval. LlamaParse exists to fix that very first step, and the idea behind it is elegant. It treats each page as an image and sends it to a vision language model that reads the page the way a person would too. It sees the table grid, the column boundaries, the heading hierarchy, and it emits clean markdown with real markdown tables. Because the structure survives, a chunk like the enterprise row keeps its price and its refund window together. So retrieval can finally answer the question you asked. Now look at how little code this takes. You import LlamaParse from the Llama Cloud Services package and import vector store index from the LlamaIndex core. You call LlamaParse with result type markdown and load data on your nearly pricing PDF. Back come clean, structured markdown documents. That markdown is what you then split into nodes and index. And from there, it is the ordinary LlamaIndex pipeline, except now it is running on text whose structure survived. You build a vector store index from those documents and query what is the enterprise refund window. And it is correct because the enterprise row kept its price and its refund window together as one intact chunk. That association, the label sitting next to its value, is the whole game, and naive extraction is exactly what destroys it. Print the answer, and the table that would have been scrambled at load time is now answered correctly because it survived parsing. Here is the part that changes how you debug RAG. Parsing quality is the silent ceiling on retrieval quality. Teams spend weeks tuning chunk size, embeddings, and rankers, while the real bottleneck sits upstream in how the document was loaded at load time. If your corpus has tables, multi-column layouts, scans, or forms, fix parsing first. It is often a bigger accuracy win than any retrieval tweak you can make. Vision-based document parsing is now a genuinely job-relevant skill, and it is why LlamaIndex rebranded around document agents. Fix the first step, and every step after it finally has a chance.